Hello guys, kaise hai aap log? Hope you're all doing well. Yes, I have come up with our second video in our Target 2024 NEET in our gunshot course. So this is our second lecture from the atomic structure. Hope you all watched my previous video which is related to isoelectronic species. The questions which are asked in different NEET papers related to isoelectronic, yes, I have discussed in my previous video. Hope you all watched that. Yes, if you're not, if you still didn't watch that particular video, please do watch, because each and every video is very important for your end days of your NEET preparation or maybe any of the competitive exam preparation. Okay. Yes, and today's video we are going to see the questions related to Planck's quantum theory, Bohr's theory, and then hopefully hydrogen spectrum, which is one of the very key concept in the atomic structure. Before I move into my lecture, I would like to request everyone to subscribe to my channel. Please do subscribe, and then yes, I have been getting so much of encouragement from your side, from the student side, from the viewer side. Yes, they have been continuously giving me some valuable suggestions. Yes, I'm so thankful to all of you. But in this video today, I'm going to give you a good news that from now I'm going to be available in WhatsApp also. Please do just text me whatever queries you have. Yes, most of the students have been posting in the comments that, sir, can you please give us some relation or some kind of notes or some information, some concepts, some trick notes or short notes for this chapter and that chapter. So I can't send without knowing any of your source. Okay, or else you can also just go with my mail ID also, that is chemistry with RK. Yes, if you have any queries related to any of your competitive exams, yes, I'll be available through my Gmail, also my WhatsApp. Yes, so please do text any kinds of doubts you have related to any of the competitive exams. Yes, I'm going to respond to you as soon as possible. Thank you so much. Yeah, hope this particular initiation will help you a lot. Yes, please do take advantage of this particular source. Okay. Yeah, without any late, let's start our discussion for today. Yes, I have chosen few questions here, so which are related to Planck's quantum theory. Yes. So what exactly is Planck's quantum theory? First of all, before going to the question, let me give you the relevant equations actually. Okay. So generally, there are few parameters which every electromagnetic radiation will exhibit. Okay. So among them, the very important parameters are energy. Yes, I hope you know this, energy. And then we also have frequency, which is denoted by nu. And then we have wavelength also, which we generally denote as lambda. And then we have another one, that is wave number. Yes, so every electromagnetic radiation is going to show, actually apart from these, yes, we have some more amplitude, intensity, and some other properties also, but in this particular concept we are going to deal with these particular four terms, very important. Okay, yes, we are going to use these particular terms very much in coming few minutes, or maybe in this chapter, maybe in your physics also. Few concepts in chemistry linked to physics also. Please do get benefit of this. Yeah, what exactly we need to know about the Planck's quantum theory? Energy of every electromagnetic radiation is directly proportional to the frequency of the radiation. Yes, this is what Planck's quantum theory tells us. And then by removing this proportionality constant, we can able to write that is a constant called as Planck's constant. Okay, so that is Planck's constant. So E is equals to h nu. This is called as Planck's equation. Okay, Planck's equation. Yeah, very important for the calculation part, very important. So this and now again in the place of nu, that is frequency, we know that. Okay, so nu is equals to c by lambda. nu is equals to C by lambda. Very important. So if you can substitute nu is equals to C by lambda, then we are going to get E is equals to HC by lambda. Yes. And then again, we know that there is another relation between wavelength and wave number, that is wave number is equals to 1 by lambda. Hopefully, so from this relation again we are going to write down, that is E is equals to HC nu bar. Yeah, these three relations. So that is yes 1 and then 2 and then 3. Yeah, these three relations we are going to use to calculate most of the questions and most of the concepts actually. So let me just conclude here. So what we can able to conclude here is actually energy is equals to h nu, that is yes we know this is actually called as Planck's quantum equation. And now just now we have written this equation and rewritten it as hc by lambda, and then 1 by lambda we can also be written as hc nu bar. So if you observe, all the three equations represents the same energy relation, and now what we can able to do is just by combining all these three equations we can able to write down, that is E is equals to h nu, and now that will be is equals to hc by lambda, and that will be is equals to hc nu bar. Yes, hopefully, yeah, this is the relevant equations which we need to know to calculate or to find out the coming questions. And now from this we can even write down one more point, that is energy and frequency. And since it is a constant, since Planck's constant is a normal constant, so we can able to skip that, and then we have to write down the proportionality symbol. So that is E is directly proportional to frequency, and then again here Planck's constant and velocity of light is again a constant, so we can skip that, and then we can write down 1 by lambda, and then we can also write down these two are constants by taking it off, and then we can write down a nu bar also. Yeah, very important. Hopefully you understood. Okay, and then next by comparing this we can conclude that energy is directly proportional to frequency, inversely proportional to wavelength, directly proportional to wave number. Yes. So if suppose if we have two different energies, two different frequencies, two different wavelengths and two different wave numbers, then what is the equation we are going to get? Okay, yeah, we are going to write down the equation as, okay, we are going to write down the equation as E1 by E2, that will be is equals to, since these two are directly proportional, we can write down nu1 by nu2, and they are inversely proportional. I hope you know how to write down the lambda 2 by lambda 1, and then they are directly proportional, we can write down nu bar 1 by nu bar 2. Yes, this is what, again, very important formula which is required for our upcoming questions actually. Okay, so hope it is clear. Okay, and then let me just directly move into my first question. Yeah, and now the question here is calculate the energy in joules, calculate the energy in joules. Okay, and then calculate the energy in joules corresponding to the light of wavelength 45 nanometers. So first, for this type of problems we need to write down the given data. So that will take you to the ultimate answer. Okay, no need to worry about the answer. Don't just be in a hurry to get the answer. Don't do like that. Okay, so first you try to make out the things, try to separate the information they have given, so that that information itself will take you to the final answer. Okay, yes, keeping that point in mind, please observe carefully. So let us separate the given data first. So what they are asking us to calculate, they are asking us to calculate the energy. Okay, so we need to calculate the energy, and then they gave a wavelength. So that is at 45 nanometers. So actually we can't substitute wavelength in nanometers. Actually we need to convert it into meters. So what we need to do, 45 into, okay, so 45 into 10 power minus 9 nanometers. Yes, we know very well, very easy. And then we have a H value also they have given. Yes, actually they won't give generally, but in this particular question they have mentioned it particularly, so you are lucky. So yeah, this is the constant value we need to remember. Okay, so that is 6.625 into 10 power minus 34 joule second, or If you want to take it in ergs, then it is minus 27. And then velocity of light, they have given it is 3 into 10 power 8 meter per second. Okay. Yes. By looking at this information, just now we have discussed what is the relevant equation we need to use here. Yeah, this equation is suitable to solve that particular question. Very easy one. Yeah. So now what we have to do is you just take the formula here, E is equals to hc by lambda. Yes, directly you can substitute and get your answer. But make sure all of them must be present in same units here. Okay, so energy they are asking in joules, so we need to take h value also in joules. So h का value हमको क्या है? That is 6.63. Okay, 6.63 into 10 power minus 34 joule second. And then we have C value, that is 3 into 10 power 8 meter per second. And then we know that that is, yeah, lambda value we have got 45 into 10 power minus 9 meter. So if you observe carefully, there are few things we can cancel them. Okay. Yes, so that will be left out with only joules actually. Okay. So if you observe carefully, this 3 ones are and then 3 15s are we can write down. So that will take you to the 6.63 into 10 power minus 34. Okay, let me just take out this 10 power में एक बार कैलकुलेट करो, ये 10 पावर माइनस 9 ऊपर गए तो 10 पावर प्लस 9 हो जाएगा और ऑल टुगेदर 10 पावर प्लस 17 हो जाएगा. 10 power plus 17 and then 10 power minus 34. So 10 power minus 17 will be remaining. Hopefully you understood. Okay. Yes, this is what we are going to left out with the final one. And then if you try to take the division of this, so it is almost close to, okay, let me use the calculator. Anyway, you don't have any calculator to use in the final exam, so please be careful. So मैं तो डायरेक्टली कैलकुलेटर यूज करके हमारा आंसर को निकाल सकते हैं, पर आप लोग ऐसा नहीं कर सकते. So please just do some practice. Okay, do some practice with that. So what we have that is 6.63 divided by 6.63 divided by 15, right? So you just take 6.63 divided by 15. If you take, it is 440 yes, you can see here the answer 0.042, right? Yes, you just try to write down here. So that is 0.0, sorry, just a minute. So what is the answer we have? So yeah, let me just check it with 0.442, right? It is 0.442, okay? Yeah, so it is 0.442. And then we have 10 power minus 17 also with us. So if you try to make it round off, that is 4.42 into 10 power minus 18 joules will be the answer. Okay. So then our answer will be the fourth option. I hope it is clear to you. Next, let us move into our next question. Yes, it is also. So what they are asking us? So they are asking us to calculate the value of Planck's constant is okay, fine. Here also they have mentioned the Planck's constant value. The speed of light is very good. They have given in nanometers. Please take care of this. Okay. So we need to convert it into meters. Okay. Anyway, we will do that. So which value is the closest wavelength in nanometer for a quantum? Wavelength in nanometer for a quantum of light. Superb. So just try to separate the given data. So given data, please. Yes, you try to write down the given data. Okay. So if you try to calculate, so what they have given beta? So they have given frequency. They have given frequency 6 into 10 power 15 second inverse. Yes, very good. And then what else we have? That is h value. We know h value they have given. So h ka value 6.63 into 10 power minus 34 joule second diya hai. Very good. C ka value they have given 3 into 10 power 17 nanometer per second. But we need to convert it into meters. So we can easily do that. 3 into 10 power 17 into 10 power minus 9 meter per second. Wow. So if you just try to round off this power, so that will be, so C is equals to 3 into 10 power of, so how much you will be getting? It is 8 meter per second. Yes, that's what we had in the previous answer also. Yeah, and then what they are asking us here. Actually, they are asking us to calculate the wavelength. So again, going back to our equation, so what is the relevant equation? Superb. So this is actually yeah, if you observe carefully the first and second equations, we can able to equate them. देखो हमारा equation, पहला equation E is equals to h nu है और E is equals to hc by lambda है, और इन दोनों को हम equate किए तो so what we going to get is h nu is equals to h nu and then we have hc by lambda. So finally we can write down nu is equals to c by lambda. Yeah, this is the relevant equation for this question. Yes, and now we have everything. चलो just substitute and then get the answer. That will be, so lambda हमको calculate करना है और c का value उसने कितना दिया, so that will be 3 into 10 power 8 meter per second divided by, so nu का value हमको है 6 into 10 power 15 seconds, sorry second inverse. Okay, so ऊपर भी second inverse होगा. ओके, सो ऊपर भी सेकंड इनवर्स होगा, सो ये दोनों कैंसिल हो जाएगा. आंसर विल बी इन मीटर्स, बट दे आर आस्किंग इन नैनोमीटर्स, डोंट फॉरगेट दैट. ओके, सो या वी आर गोइंग टू गेट दिस 1 जा, दिस इज 2 जा, सो लैम्डा का वैल्यू हमको 1/2. सो इफ यू ट्राई टू ब्रिंग दिस इनटू द न्यूमरेटर देन दिस विल बिकम 10 power minus 15. सो 10 power minus 15 और 10 power minus 8 कितना आएगा, सो 10 power minus 7 आ जाएगा. सो 10 power -7 आ जाएगा and then meters. Okay, and then 1/2 का वैल्यू कितना लिख सकता है, 1/2 is we know very well 0.5 into 10 power -7 meters actually. So what we can able to write down, this is nanometers actually. So 50 into 10 power -9 meters we can write down. So finally our answer will be coming out as lambda is equals to 50 nanometers. So the answer will be 50. Hope you understood. Yeah, so problems are actually to we have to practice more. अगर कुछ calculation का part है, yes we have to practice it compulsory instead of skipping that. Okay, so what generally students do while doing the calculations in the problems actually, so they just worried about the formula, and then once after they get their relevant formula to solve that question, they will just think that okay ये हम बाद में करेंगे, ये हम बाद में solve करेंगे, ये formula तो आ गया तो आंसर भी easily आ जाएगा. Please don't do that. Yes, you have to practice so that you will get to know the techniques also. Okay, let's move on to our next question. So that is, according to the law of photochemical equivalence, the energy absorbed in, okay, they have mentioned particularly ergs per mole, okay, and then is given as, okay, fine, and then centimeter inverse, okay, fine, okay, right. So let us now just go for the relevant equation. So if you can able to understand the question, here they are asking energy पूछ रहा है. okay, so they are asking us to calculate the energy. They gave h value, they gave c value, and they also gave Avogadro number value as well. And in your final answer, if you see, the lambda will be as it is, so no need to worry about the lambda. Let us now just move on to the relevant equation. Actually we know that E is equals to hc by lambda. But since we are having photochemical equivalence, we need to take the Avogadro number also in the calculation. So that's it. If you just substitute all the values in that, then we can able to get our answer easily. And then every value they have given here, that is 6.62 into 10 power minus 27 ergs erg second, sorry. And then what do we have, 3 into 10 power 10 centimeter per second. Okay, and then actually just a minute, yes we have something else also, 6.02 into 10 power 23 mole inverse actually. Okay, yeah, fine, and then divided by wavelength as it is. So just what we need to do is, lambda के बारे में सोचने का जरूरत नहीं है, पर न्यूमरेटर का वैल्यूज को सबको मल्टीप्लाई करो and then try to find out the 10 powers and then that will be your answer. Okay, so just to take the help of 6.62 into 10 power minus 27. Okay, so let me just use the calculator. मेरे लिए कैलकुलेटर तो easily available है, आपके लिए नहीं होगा. So एग्जाम में कैसे करता है, so please do practice. Okay, so calculations हमको ज़्यादा से ज़्यादा करना है. So what we have got, the final answer is 119.5. Okay, let us take the same thing here. So that will be 119.5 into, so actually the 10 powers में कितना होगा, 10 power 23, 10 power minus 27, 10 power minus 4, 10 power minus 4, and then 10 power 10, 10 power 10. So how much it will be? Actually ergs will get cancelled. So you will be having अगर हमने नीचे wavelength का value अगर सेंटीमीटर में लिया समझो, and then we can also cancel these two, and then the answer will be in erg per mole. Okay, that's what they are asking. Okay, so fine, we are going to get 10 power 6 hopefully. Okay, so 10 power 6, because 10 power minus 27, 10 power plus 23, 10 power minus 4, 10 power minus 4, 10 power plus 10, it is 10 power plus 6, and then divided by lambda. Don't forget this. Yeah, finally इसको हम कितना लिख सकते हैं, that is 1.196 or 5. Yeah, and then since it is moved to the left side, then we can increase the power by 2 units. Okay, yes, so final answer is 1.196. okay, anyway, don't forget the units also here, ergs per mole. Yes, and then what we can write down, so this will be the answer. Okay, yes, hopefully you understood. Okay, and then this is how we do solve the questions actually. Let us move to the next question. So we have something actually here, this question is particularly related to the ratios actually. Okay, so the energies E1 and E2 for the radiations are, okay, fine, very good, so simple. So if you just go back to our formula slide, and then yes, here there is a relation between energy and frequency of the radiation. Okay, and now by using or by taking the help of that particular equation, so we can write down here, that is energy is E1 and then energy is E2 they have given. So that will be 25 electron volt and then 50 electron volt. Okay, and the relation between their wavelengths, sorry, not frequency, they are asking about the wavelengths. So lambda 1 lambda 2 को हमको relation लाना है. Okay, so yes, let us just try to understand. So what is the equation we can write down? Energy is actually inversely proportional to wavelength, right? So from this we can write down E1 by E2 is equals to lambda 2 by lambda 1. Yes, this is so simple. And now we have anyway, so that will be lambda 2 by lambda 1 is equals to 25 electron volt by 50, okay, 50 electron volt. Okay, so electron volt cancel, 1s are, 2s are, so we can write down that lambda 2 by lambda 1 is equals to 1 by 2. So if you observe carefully, try to check the options, so we can write down lambda 1. So इधर से हम क्या लिख सकते हैं, lambda 1 is equal to 2 into lambda 2. So this will be the answer, where it is lambda 1 is equals to 2 into lambda 2. So that's what they are asking. Okay, so no need to worry about the answer. Okay, just you try to write down the given data, so that we can able to bring out our answer very easily. Yeah, okay, and then next let us go for the next question, that is the value of Planck's constant. Actually, if you observe carefully in all our videos, yes, the year which I have shown here, that will be describing about the in which year the question is asked actually in NEET actually particularly. Okay, so just 2003 में I hope you understood, बहुत सारे बार अभी Planck's quantum theory से questions आते रहे. Okay, so we have to give obviously some priority for this Planck's quantum equation when we are preparing for JEE or NEET exams. Okay, yes, let us continue. So what do we have? So Planck's constant is, okay, again Planck's constant का value दिया, so that is h का value दिया है और c का value दिया है, और which value is closest to the wavelength in nanometers when it is frequency दिया है, that will be 8 into 10 power 15 second inverse, and then इसका value 3 into 10 power 8 meter per second. And then actually इस question में Planck's constants का ज़रूरत भी नहीं है, because the equation doesn't have the relation is wavelength. Okay, yes, we need to calculate wavelength. So this is the equation we need to use to solve this question. Okay, yes, let us take the help of this equation. So nu is equals to c by lambda. So we have that lambda is equals to c, that is 3 into 10 power 8 meter per second, and then divided by that frequency we have given that 8 into 10 power 15 second inverse. Okay, so second inverse will get cancelled, and then again they have mentioned particularly wavelength in nanometers. Okay, they have mentioned wavelength in nanometers, so we need to convert it. So that will be 3 by 8 into, so if it goes into the numerator, then it will become 10 power minus 7 meters actually. So yeah, if you calculate the value of 3 by 8, 3 by 8 ka value hai, so it will be coming out as, so 0.3, so it is 30. If you take a point, then you can able to get it as 0.3, and then you will be left with 6 and then 7 and then 5. Okay, so closer values actually, so 0.375 something. You please try to calculate it particularly. Okay, and then you can write down this as 10 power minus 7 meters. Okay, and then next if you try to write down this as 37.5 into 10 power minus 9 meters actually. This 10 power minus 9 meters को हम क्या लिख सकते हैं, nanometers लिख सकते हैं. So we can write down that there is 37.5 nanometers. So if you observe carefully, we have closest to the wavelength in nanometers. So they themselves given that we are not going to get the exact value, we will get the closest value. So you can take it as the closest value, round off, you can round off. So what we can round off is 37.5 is close to, that is 40 nanometers. Okay, so is 40 nanometers को हम कैसे लिख सकते हैं, that will be 4 into 10 power 1 nanometers. Yes, we can write down very clearly. So the answer will become, let us move into our next question. So that is asked in 2020 NEET. So the question is related to energy. They have given wavelength they are asking. Okay, so energy, they have given energy. So that will be 3.03 into 10 power minus 19 joules actually. Okay, and then the wavelength they are asking, we need to calculate the wavelength. H का value दिया है और C का value भी दिया है. Okay, and then we can take the help of what is the equation, required equation for this. Yes, we have been continuously solving so many questions, so you have to get some idea into your mind. Okay, E is equals to hc by lambda. And then next if you try to calculate this value, that will be E is equals to, so what is the equation, what is the value we have, 6.626 into 10 power minus 34 joule second. And then we have 3 into 10 power 8 meter per second, and then we have that will be, they are asking us to find out the wavelength, right? Yeah, so energy ka value diya hai, so that will be 3.03 into 10 power minus 19 joules. Okay, so here we can cancel out joule and then second. So you are going to get the answer in terms of meters actually. Okay, observe 6.626 into 3. What is the answer actually? 19.8 actually, right? So that answer will be divided by 3.03 actually. Okay, so what we have got here, that will be 6.56. Okay, yes, 6.56 something. So 6.56 into, so how much is the remaining from this 10 powers? So the 10 power minus 19 comes into the numerator, plus 19, and then plus 19 plus 8, it will become plus 27. So 10 power minus 34 into 10 power 27. Okay, so how much will be remaining? 6.56 into 10 power of minus 7. Okay, so 10 power minus 7. So is there anything like that? No. Okay, so we can write down 10 power minus 9. इसको हम क्या लिख सकते हैं? 656 into 10 power minus 9. Actually we have in meters. So and now we can write down clearly, that is 656. In place of this we can write down nanometers. So answer will be D. Hope it is clear. So actually the problems are very easier than conceptual questions. Okay, generally some students feel that problems itself they feel very easy, very comfortable in solving. Some students feel that conceptual questions are very easy to solve. Okay, it depends or it differs from student to student, but being a teacher, I can say I must say this, because conceptual questions and then problem questions are all NEET or mains questions itself. So it's the only intention, only the mindset you have prepared in your mind to attack that question actually. So you should not give, you should not be in that type of thought process actually. So you have to treat all questions in one particular manner only. They're all questions actually, okay? Problems and concepts, they are not actually different, okay? Let us move into our next question. Yes, okay. This is related to hydrogen spectrum that we will see in our next lecture, okay? Yes, this particular video I have included questions related to Planck's quantum equation and electromagnetic radiations. So since you have seen, all those questions are actually tricky, but they are easy, okay? So yes, I request you to go through the video lecture properly, and so I request you to just maintain a separate notes. You try to prepare a separate notes, or you try to write down all these tricks and then formulas in one place, so that it will help you in your final days of your NEET or JEE preparation. So with this, I am going to end up my video. So soon, we are going to see the another Target 2024, that is gunshot course, with our third atomic structure lecture on hydrogen spectrum and Bohr's theory. So finally, I would like to request, if you are new to the channel, please do subscribe, please support my channel, please do spread my channel. Yes, I am going to take so many initiations which helps the students, those who are going to appear for 2024 NEET or 2024 mains. So actually, in our coming lectures, you are going to see so many different initiations which is going to give you more benefits out of my videos, okay? So thank you so much for watching the video. Thank you. See you soon.